Practice final for Algebra 2 final exam. Number 24. What are the slopes of the asymptotes? So here is my equation they're giving. So if they're asking me asymptotes, then it is a hyperbola. Now, what a lot of people try to do is they try to get rid of these numbers here, and you are, but you got to think of it as more of, you got to make this thing equal to 1. Okay, so I'm going to divide everything by 36. So this turns into x squared all over 9 minus y squared all over 4 equals 1. Okay. So to kind of sketch this thing, this is centered at 0, 0, right? Because there's nothing being added to these values up top. And in the x direction, we go 3 because it's the square root of 9. Okay. And in the y direction, we go 2 because it's the square root of 4. And then from there, we draw in our box. Okay. Now from here, these are your asymptotes, right? There goes that. There's one asymptote. Sorry, it's not a very straight line, but there's another one, and there's the other one over there. Okay. The asymptotes, when they ask you for an asymptote, it has to be in y equals mx plus b. When the center is 0, 0, b is going to be 0, so you don't have to worry about that. So it's just really the slope. And the slope comes from rise over run. So I'm going to say this goes up to and over 4. So the asymptote is y equals plus or minus 2 over 4x. To simplify a little bit, sorry, oh, this goes over 3, not 4, sorry. 3, and then that would be our answer because you can't simplify that. So you go over 3. All right, 26. Number 26 says, what is the vertex of y equals 3 times x plus 6, quantity squared minus 5. So this is a parabola, and the vertex is going to be, this is our HK form, if you remember. Remember, when it's in parentheses, we always change the sign, so the vertex is -6, -5. This is outside the parentheses, so we don't change the sign. 28, find the focus for number 28. Okay. And basically what you can do here is, so I'm going to rewrite that as -1. I told you to get this term isolated by itself, so I'm going to multiply everything by -1. So now I get -1 times y equals x squared. Now take this number right out in front of the y now, and you divide that by 4. That was part of our formula, and that gives us p. Okay. Now, if you're asking for the directrix, it would be the opposite of that, so it would be positive, but in this case it's focus. Now the focus is, if you had a parabola here, focus is inside there, so it's always going to be added to the y value of the vertex. So this original parabola we had up here, I know I wrote all over it here, but it was this right here. That is a vertex of the center 0, 0. So the focus is on the same line of symmetry as the vertex, so we're going to add -4, right? So we're going to add -4 to it, so the answer should be D. So it's the coordinate point 0, -4. Right. Let me just double check that answer. 28 is D. So it looks like the parabola actually would have opened down. I just kind of threw that picture together trying to give you an idea where it could be, because your focus can also be inside the parabola. It's going down. All right, 30. Number 30 says, find the vertices. And this is a hyperbola. I can tell because it has a minus sign. It's equal to 1, so I know it's a hyperbola. If I was to sketch this thing, this is centered at 0, 0. Okay. So, because the reason, if you're having problems figuring out if it's centered at 0, 0, this right here is the same as that right there. Okay, if you don't write anything next to it, like that's what the 0 is. So that's why we're centered at 0, 0. So in the x direction we go 2. In the y direction we go 3, taking the square root of 9. And then you would draw your box in, right? So when it comes to a ellipse, the vertices are whichever one of these values are bigger, b squared or a squared, right? With hyperbola, that's not true. With hyperbola, it's every which one comes first. So this hyperbola, the vertices are right here, because this thing would be going in the x direction, you know, something like this. Okay, just to kind of give a quick sketch. These are the vertices. So the center is 0, 0. So to find the vertices, we would add 2, and we're going left to right. 2 or minus the to the x coordinate, so the vertices are actually plus or minus 2. Number 32. Now we're into probability, and this is where where a lot of people were really having problems. There's a lot to this. 32 says, out of 20 softball players on a team, 2 are selected at random to be co-captains. How many different combinations are there? What you got to understand here, it doesn't matter who was picked first. It's still the same 2 people, so the order is not important. So this is a combination. So there's 20 possible players. There's 2 that are going to be selected, so it's 20C2. And so this would equal 20 factorial all over 2 factorial times 20 factorial, 20 minus 2 factorial. Okay, you can put that into your calculator. But this simplifies pretty nicely. Okay, so we simplify from 18 down. So we're looking at 20 times 19 all over 2. Leaves us with a 10 right here, and that leaves us with 190 different possibilities. Okay, that's how many different combinations you could have of team captains. All right, moving on to 34. How many different distinguishable arrangements can be made using the letters? Okay, you're looking at the word main. So distinguishable arrangements is the way you want to look at it from the perspective. It's a it's going to be a permutation. Okay, I forgot the word for a second. It's going to be a permutation because it matters the order, right? So if you have the word right here, okay, what they're saying is they want to know. It's down. They want to know. Well, you know, you have this one. I could switch. All right, and I can go. You can see all the possibilities of rearranging these things. So this is where order matters. So this is the permutation. There is 2, 4, 5 letters in there. None of them repeat, right? So we're basically going to say 5p5. And if you remember, this is also an example of just 5 factorial. I'll show you that in a second here. So you could do 5 factorial all over 5 minus 5 factorial. This is always tricky for people. It really is an odd thing, I know, but 0 factorial equals 1, not 0, so this is actually 5 factorial. Okay. The other way to just kind of reason your way through this was just to use the excuse me, the counting principle. It says you got 5 letters, okay, and you have 5 options for the first one, 4 for the second one, 3, 2, and 1. And you can see that is, in a sense, is 5 factorial. Okay. That was 34. 36. 36 says Kristen repeatedly drew 1 card at random from a deck of 52 and then put it back. What is the probability of Kristen drawing clubs 3 times in a row? So you have to understand she's putting the cards back. So there's 4 different suits in a set of cards, deck of cards, and if you and they're even numbers. So if you divide them up, that's 13 of one particular suit. So the chances of her pulling a club the first time is 13 out of 52. She puts the card back and she wants to draw a club again, so the probability remains exactly the same. And the reason I know to multiply these is because there's more than one event taking place, right? She's drawing, if they draw more than 1 card or pull 1 marble or do whatever it is, something more than 1 time, that's an and situation and you're multiplying. Right, and then you can go ahead and multiply this out. And this is really just going to be 1/4 times 1/4 times 1/4, and that's 1 over 64. I think 4 to the third is 64. Okay. 38. Okay. And then we're looking at 38 says which formula can be used to determine how many cleanup committees comprised of 4 boys and 3 girls can be made if there are 6 boys and 5 girls to choose from? The answer is D, I can tell already, because you're choosing 2 different committees. Okay, you have to have 4 boys, and you have to have 3 girls. The boys, and when you pick them, they don't overlap at all. You're not drawing from the same. So since you're drawing from a different sample, you're pulling 6 for the boys, and you're going to get 4 boys from the group of 6, and you're going to get 3 girls from the group of 5. They're different combinations because it doesn't matter in which order we pick them. Since they're different combinations, you cannot do them simultaneously. So the answer has to be D, because you would basically find that's the combination for the possibility for boys, because there's 6 boys and they're only picking 4, times the combination of there's 5 girls and 3 of those. Okay. Moving on to question number 40. Find the probability of drawing 1 card from a standard deck of cards and it being a club or a 9. So the main thing here is we are drawing 1 card. So this is an or situation. There's only 1 card being drawn. So let's say, what's the probability of drawing a club? Well, that's a suit. So there's 13 out of 52, and don't reduce these because we're going to add them. We like having common denominators. And then how many 9s are? Well, there's 4 9s. Okay, and a lot of people would be satisfied with that. However, the issue is there's some overlap. Okay, because there is 1 9 that is a club. We can't count that card twice. Okay, so we work this out. We're basically looking at 3/10 over 52. Reduce the fraction, 5 over 26 would be your probability. Okay. That was number 40. Is that an option? Let's double check here. Not seeing that one. Hold on. So 13 minus that is 17. Oh, sorry. I got to work on my addition here. I subtracted twice. So 17 over 52 minus 1 over 52 equals 16 over 52. Scratch that. Don't want to subtract that one from that one. And then reduce that down, and we'd be basically looking at, take a 2 out, 8 out of 26. I got to keep on going. 4 out of 13. And that one is an option A.